Okay, let's do the next bit on this, materials. And hopefully this will be a review from Introduction to Manufacturing. But it's materials and manufacturing. Some people say there are only three basic categories. I'll say there's four. Composites. Basically, composites are made up of the other three: metals, ceramics, and polymers. But their chemistry, physical properties, everything's different about these things, right? It goes back to basic chemistry. And it affects how you do make these things, what you do to them, what you can do to them, what you can make with them. So metals, these can be in pure form. Think of gold or silver or copper, but most of them are alloys, which means you took two or more elements and mixed them together, and this changes the properties of it. Two basic groups, ferrous metals. These are based on iron, which is about 75% of the metal tonnage in the world. And we talked a bit about that in the introduction to manufacturing, how at one time it was all floating in the ocean, and then actually as the plants produce oxygen, they got oxygenated and fell to the bottom. So we mined basically the rust that fell out of the ocean. Big one is steel, right? And that's got just a little bit of carbon in it, right? 0.02 to 2.11%. I'll let the metallurgy class talk a little bit about why that's good. And then you got cast iron. Basically, you got the same elements, but in just different proportions, 2% up to about 4% carbon. Again, now I'll let metallurgy talk about that a bit. Then you got the non-ferrous. Again, this is anything that doesn't have iron in it. So you got aluminum, copper, magnesium, nickel, silver, tin, titanium, etc. And look at these aren't usually alloys. There's some. I take that back. You mix tin and copper together, you get brass and bronze. But you're likely to find these in pure form. Ceramics. These are they can be metallic or semi-metallic and non-metallic. Um, but usually non-metallic are like oxygen, nitrogen, carbon. And if you think of like the clay, just pure clay, that's traditional, right? So what they'll do is they'll pick up all this clay, mold it into whatever shape they want, bricks or pots or whatever, and then they just heat it, and it undergoes this process called vitrification, which it kind of turns to glass, right? So if you ever break open like a brick or a pot, or especially cheap pots, you can look at the different layers. You can see the vitrified outside, and then it might be a little bit soft on the inside, and that's because they didn't cook it all the way through. And you can do the ultimate, which is porcelain, and I'll look for a video that shows porcelain. It's kind of a neat process, because without porcelain, we would not have steel. And I'll get into that later, maybe. And then you got the engineered ceramics, and basically scientists just add different elements and change the properties. Look on the bottom of a spacecraft as it comes in. Those are engineered ceramics. They take a lot of heat, right? And then you got glass. Glass is basically just sand, silicon dioxide. That's a type of ceramic. Okay, let's talk a little bit about plastics, in particular polymers. Polymers are made up of monomers, which are just joined together, make these long strands that they call polymers. What you can do then is you can heat up these polymers, and they'll separate from each other. The polymers themselves, not the polymers rarely break up. Well, you don't want them to break up, but you can separate the polymers and form into whatever you want, and very easy to work with. Just melt and pour and blow and whatever you want to do to it, right? Inject them. That's probably why there's so many plastics, and you can do a lot of things with them. But watch the video. So there's three different types. There's the thermoplastic polymers. These are the kind I just talked about, where you can actually take the polymer strands and separate them and reform them. But there's nothing to stop you from reheating them, separating them again, and forming them into something else. Perfect for recycling. Thermosetting polymers. These ones actually the polymers interact with each other. So when you melt them, they don't melt the same. They'll just break up and just basically just be a glob of something, but it's not a polymer. And the last one is elastomers. A lot of these rubber gloves are just really just polymers that can stretch out, stretchy polymers. So what you can do then is you can combine all these things, the metals, the ceramics, the polymers, and make a composite. You think of things, well, there'll be a slide that'll show you some things, but Kevlar, things like that. I'm going to include a video on graphene, uh, which should be pretty close to being used in composites, bulletproof vests, things like that. But composites are just mixtures of the other materials. So what is a composite? Well, it's a material consisting of two or more phases. What is a phase? Well, it's just a clump of stuff that's all the same, right? Similar material. If you go on to metallurgy, you'll see you go into phase diagrams, but they're processed separately. So you take care of the same metal and bond together to achieve properties superior to its constituents. So you got, let's say, metal, and then you got carbon fiber. You glue them together, and you keep on stacking those up. You got a composite, right? So when you mix these up, then the properties of the components and the physical shapes of the components, you can get them the way you want in the final material. And what does that result in? Stuff like this, right? You get composite skis, composite wings in a fighter jet. You get water skis are composite. Everything's made out of composites, right? When I was a kid, I remember when, well, it used to be metal, aluminum tennis rackets came out, metal tennis rackets. They were kind of cool over the wooden ones, right? But then they came up with graphite tennis rackets, which was a composite, much lighter, much stronger. And I don't think you'll find a tennis racket that's not made out of composite anymore.